All right. So hello again, all. I'm Yasin, as you know me. First of all, I really want to thank all of the builders for the great efforts for the last 3 months. And zkIgnite has been really the core of our ecosystem in terms of growing and building the future of Mina. So it has been an amazing journey and great experience with you guys. You really made our jobs easier for this cohort, and yeah, I'm really keen to see what you guys built after all. And just like to just to remember, your presentations, like each presentation will be 30 minutes. Like we recommend 20 minutes of presentation, which is mainly showing your product, explaining the code, and giving some time to electors or the folks here to ask questions regarding your milestone. And as we have been taking records of these presentations, we will send it to assigned 5 electors, and they will vote on your milestones if you hit the milestone or not, and you will receive the results on 26th January. So that's it. I think in terms of not to lose time, let's give a start with Ranuk. Ranuk, are you there? Are you ready?
Yeah,
Okay, so I think you can start then. Yeah, good luck.
yeah. Let me share my screen. I'm sharing my screen from the other account that joined on this call. I hope that's fine.
Yes.
Yeah. So,
It's
hello. Yeah. Welcome everyone for the demo of my zkIgnite project. My zkIgnite project was to build a platform to host sale bid auctions, but I have slightly expanded on that to create a platform to host any kind of auctions, particularly for NFTs. And I have decided to use ProtoKit for the development. So it's more like a NFT market on a ZK rollup. So let's first start with the uh, uh, GitHub repo that I created. So as you can see, I created a public org and there is a single repo. So it's a monorepo and it has many different packages and the front end in the apps directory. So let's first go through the chain package. So it contains all the runtime definitions for the app. So runtimes are essentially like smart contracts. So it defines the user actions or the state changes that are allowed on the ZK rollup. So I have created some basic runtimes like the balances and the NFTs, and I have also created the runtime models for different kind of auctions, as you can see here, and also a private token. So the purpose of this private token is that uh, you if a user can deposit their normal token to the private token and then claim that deposit at a later point. So to which will essentially obfuscate their balance with the unclaimed deposits so far. So it's essentially like a tornado cash. So the longer you wait, the more privacy it will have. So, but unlike tornado cash, the you will get an encrypted version of your balance. So, and using that encrypted balance, you can later participate in other functions like bidding in the blind auctions. Yeah. So, so so let's then come to the blind auction. So as you can see, like I've created a blind auction. So here you can participate in the blind auctions and all the runtime modules I've created like extensive test cases which covers which starts for all the functionalities of that runtime from the start to beginning. So if you want to take a look at the code, I would recommend starting with the test cases because it will it covers how to use the runtimes nicely. Yeah. So and let's again quickly go over to the other packages. So another important one is a data service. So it's essentially all the backend services that's needed for the app. So like there is an indexer and uh, that I built, which essentially indexes the blocks produced by the sequencer and updates the DB. And I've also created a data service which stores all the data in a nice format in a Mongo database. Yeah, and other important part that I built was the front end. So I use Felt Kit for it. So let me show you the front end that's currently. Yeah, I currently there is a front end running in the background, and I have the and there is also a local indexer and the data services running. So like, uh, so let me start from the beginning. So at the beginning, you have to connect your wallet to view the my NFTs, and so I've already minted some NFTs for this address. So uh, then I can create an auction for one of the NFTs. So let's create an English auction. Let's put it as 2 days time, and after I sign that transaction, so the all the transactions are like similar to Ethereum. You just need to sign it, and it will go to the sequencer and it sequenced. So it's really fast. The client don't need to prove anything. So after that, so you can see that it's in the auction, and I can also see that in my auctions page, like the auction got created. So now let's sign in through the another account. So these account have different set of NFTs, and then so this is the home page of the application. Here, when a user comes in, they can see all the auctions that's currently happening in the platform. So currently, he can see that there is only one auction, and he can place bid on this. Mm, but currently, he has no balance, so you need to first mint some tokens. So I created this sample, this button to mint these test tokens inside this app chain. So after the transaction succeeded, I got some balance. Now I can place some bids. Uh, let's put 100 for this. So after I signed that transaction, so so I can see in my speech section that I can see all the bids that I placed, and in the live auctions, it's showing the highest bid is 100 till now, and the auction will end at that after this amount of time. So I can see that there is like 100, like my balance was reduced by 100, and uh, it's and yeah. So let me talk about these things. So this is the private balance part. So when I open this app page, like the front end creates a private wallet for me. So this private wallet has a different private key, and now I can deposit this public balance to this and then claim that to get some private balance, and then I can also withdraw those private balance. But we need this for the blind option. Yeah, then I can, so, and I can also change this account. Just change this to another account. Uh, I change it to fast auction, and in those auction that I change it to the first account, and I can see that someone had bid on this bid, a bid on my option, and I can also place bid. So what happens is that if someone outbids my bid, like I get my original bid back automatically. You don't need to do anything. Yeah, that's essentially it. But so currently, the sequencer that is running will currently does not support the blind auction part because of some errors with protocol. So which will hopefully get fixed in the next update. Yeah, so that's it. Like if someone has any questions, you can ask them.
Well,
Well then, yeah, Will, please go.
yeah, I was just well done. It's really cool to see this level of delivery in just a short period of time, and I really like the UI as well. Two questions. One, can you speak a little bit about the process of working on ProtoKit and like the lift required for running your own sequencer and how you like thought about making that decision? That's the first question. And then the second question is next steps for the project in terms of um, your roadmap, what you want to do with it, if you have commercial intentions in terms of running a business. Um, yeah, so do those questions make sense?
Yeah, sure. So yeah, really great questions. So let me start with like uh, at first I implemented some parts of the project like a private token in uh, like managing market trees in native in normal Mina orange using oranges. But what you end up doing is like you have to manage your own smart contract and you essentially end up building some sort of roll up yourself. So but so it's essentially you are building your own protocol. So that's why I switched to protokit, and like building on protokit is great. Like you don't need to think about the Merkle tree, like your state management. So it's more similar to EVM, like. And yeah, so protokit definitely has some challenges because like it's a new project. It's a new project in development, so there are some errors. But I had worked closely with the protokit team, and they did a great job delivering and fixing everything. And so currently the sequencer is running locally, but soon we will be able to run that in some hosted environment. Like so, waiting for the protokit team to get that feature done.
Great, great. And thank you. And in terms of next steps for the project,
Yeah,
what
sure,
do you
sure.
envision?
So yeah, yeah. So let me tell you what I think the end goal should be. So what I envision is that uh, like we have to work on the bridging aspect. So what I mean is that users will be able to bridge NFTs from the L1 chain, which is Mina, and so ultimately from other chains like Ethereum or EVM chains through bridges, and then they can trade or auction their NFTs on this platform. So what advantage they will get is like the fees will be super cheap, and what I hope to achieve is that through the cheap fees and like the auction and the ease of creating auctions, that it will help in better price discovery of NFTs. Yeah, that's like the end goal. So like the next step that I need to work on is that the bridging aspect, like bridging NFTs from a Mina chain to this app chain.
Interesting. Yeah, that makes sense. Great. Thank you. Thank you very
Yeah.
much. This is really great work in a short period of time.
Yeah, and also like the front end is like have many missing elements like the in the home page you can see like this is the blank section. It will get filled with other things like filtering NFTs and all that like that you see in the OpenSea and all other places. So we
Great.
have to the front end also needs work.
Great. Does anyone else have any other questions? Okay. All right. Well, thanks again for taking the time and coming to present to us.
Yeah. Thanks, Onok. And next one is zkIgnite.
Hi guys, can you see?
Yes, we can see you.
Yeah, yeah. I'm Shreyas. I'll be presenting Ziki Snap today. Let me just share my screen. Okay, see?
We can't see. No. Oh, I think it's coming.
Oh, yes.
Okay. Yeah, it's we can see now.
Good. I'll just go over like a quick recap on like what Ziki Snap is basically. So Ziki Snap is a verifiable on-chain DAO voting solution. So what the current voting challenges is like if you see go in the market, see there are like two things. The one is like blockchain voting, which is completely open, and another is like centralized voting, which is not good. So like what blockchain voting encounters is bandwagon effect. Bandwagon effect is something like someone really popular votes for some particular thing, some particular opinion. That opinion gets followed by other people, like they just blindly follow it. So there's no element of privacy. So what we at zkSnap do is we're trying to eradicate that. We're trying to get private voting for everyone. And we want to make it off-chain as well. We don't want any on-chain components so that users don't have to pay for them to vote. Currently, like we have planned to use storage proofs later on. Currently, we are using sort of like a voter whitelist, a simple Merkle tree, which verifies if you're eligible to vote or not. We used delayed encryption. So at the start of the voting period, there'll be an encryption key which will be encrypted at the start of election and only be revealed after the election concludes, so that no one during the election can know what the votes are being done. So what we use over here, and obviously recursive snarks, we take advantage of Mina's like OJS's recursive proof capability, and like we don't need to maintain like a large state of all the user proofs that we have to like combine later on. We can just do it as we go. We also employ a very revolutionary technology called partial homomorphic encryption. What it means is basically, if you guys can see, like currently, if there is blockchain voting, I vote, my vote is there, like visible to everyone. But what if I encrypt my vote and then send it? But on top of this, we can have like an encrypted tally as well. So once I vote, I encrypt my vote, I send the vote to the aggregator. The aggregator, without knowing anything, can add my vote. It's called homomorphic addition. So this is one really cool tech we have employed. So what at the start of election, we generate a public key pair, which is so what homomorphic encryption uses is like it's basically public key encryption. There's a public key which is used to encrypt things, and there's a private key which is used to decrypt all the votes. So what we do is like at the start of the election, we generate a public key private key pair. We encrypt the private key using the delayed encryption, so that is the private key is only decryptable available only after the end of the election. So during the election, only the private key is available. Everyone can come, encrypt their vote using the public key, send the vote to us. We can add the vote homomorphically without anyone knowing what the actual vote was. And then at the end of election, we can just decrypt the individual, like decrypt the final vote tally without even knowing what the individual votes were. Now during the election, we have used client side proving, so everyone generates a client proof that they are part of the DAO or like whatever organization they are voting for. They have generated the vote successfully and encrypted the vote successfully. This proof is sent to the aggregator, which recursively checks if the vote was valid or not, if the member is currently like correctly in the like is a member of the DAO or not, and has the voter voted before or not. So we use nullifiers for this. and the vote is like homomorphically added, so we have a constant tally, like we have a running tally of the current votes. And after the election, like every like the like after the election, we can decrypt the private key, we can get the final proof from the aggregator, we can decrypt the final votes and like publish the results. So this was a short intro. I'll just go ahead and show a demo right now. uh so if I go here, correct, make a new proposal. Sorry, 17,651. So this is the flow, like how the what the admin or like anyone who has a permission to create votes will see. We'll just run a proposal for like 5 minutes. Now the proposal is like successfully created. We can see over here. In like a minute, the proposal will be open for voting. Just as this turns like 6:53, will be able to vote. So this is how general flow for any voter will look like. They will not have to pay anything. I've connected my wallet already. So currently we're using Oro wallet because it supports like creating nullifiers using the plume scheme, which OpenJS has inbuilt. So currently the time is 6:53. I can generate a vote. If I say no, but we can have any arbitrary like options over here based on the proposal. So currently it's asking me to create the nullifier. So for creating the nullifier, we use the secret key, which is like inside the wallet. So this the wallet creates a nullifier for us, and we can verify it inside the zk snark. So currently what is happening in the background is like we are generating a user proof, which I already mentioned, that is proving that the me, I am the member of the DAO, and I have encrypted the vote correctly. So if it's yes, it is encrypted correctly or not. If it's no, if it's encrypted correctly or not, which is happening inside a zk snark. So like what we're employing over here is called verifiable homomorphic encryption. So it's like anyone can do homomorphic encryption outside the circuit, but like employing it inside a circuit is a difficult task. Uh, this currently takes a bit of time because we are yet to like adopt to the latest version of Mina. Like while this vote is being generated, current like the future things we are trying to do are like storage proofs. We are currently developing storage proofs so that right now there's a voter whitelist. The like the DAO has to maintain a members list, which is converted into a Merkle tree. But later on, we can like have storage proofs, so we can directly take storage proofs from Ethereum or like any blockchain, like EVM blockchain, and prove that a person holds a certain token inside the circuit without needing of a whitelist or anything. We'll just wait over here for the vote to finish.
Sorry, this is great to see. Sorry to interrupt. Can you go a little bit deeper on that topic, specifically
Which
around
token?
being able to prove that a user holds a specific token outside of the Mina ecosystem inside of a circuit?
So yeah, so basically how storage proofs work is like we can create a whole proof. So Ethereum has like storage slots for which there is like a Merkle Patricia try proof. So how like it storage is like laid out in Ethereum, like the Ethereum storage is like using Merkle Patricia tries. So what we can do is like we can provide a try proof inside the circuit, like the storage key and storage value, right? Basically what a token is that my address should have a certain balance. So what we can do is like we can prove that this key pair exists in the Merkle Patricia try at a certain block number. We can prove
Hmm.
it inside a circuit, And then automatically we know that this person holds a certain token. Suppose USDC, right? I can find my USDC address, like the storage slot, and then prove that I hold a certain token at this point of time. Like I had like 100 tokens at block number 10, something like that.
Hmm. That
Well,
makes
so which
sense.
will like
Yeah.
open up a lot of things. We can like prove like this will open a lot of things like tokens, NFTs. Like anyone holding a certain NFT will be able to vote. Later
Yeah.
on, we can have like quadratic voting or like weighted voting as well. Based on the number of tokens, you get like a certain power to vote. So if you have like 300 tokens, you have like a 300 voting power, something like that.
Yeah. Understood. The programmability of the voting systems could get really interesting with this, and not just specific within the Mina ecosystem. Thank you.
Yep.
Yeah, please. So sorry to interrupt. Please continue.
So it's taking a bit of time for generating the vote.
Yeah, sure. So I just might have a follow-up. How do you ensure that the proof is from the canonical part of the chain? Say if you're proving a Merkle Patricia proof from Ethereum, how
Mhm.
do you prove that this is like a valid block on the Ethereum network? I'm
Chris,
not
maybe I can take this one.
Sure.
sure.
Okay, so how proving a specific state commitment from Ethereum, basically at Genesis, a state. So in the current model, you have a whitelist root, and that's just like the root hash of or the root commitment of a Merkle tree. Similarly, at genesis of any any specific vote, all you have to do is you
Mhm.
have to take the state commitment or the state hash at any particular block. Suppose my block is
Mhm.
10,000. At that particular block, I pick the state commitment and put it inside the circuit at Genesis. And because it exists in the Genesis circuit, anyone can verify whether
Correct.
the Genesis
Mhm.
of this voting is valid or not, just because they can check whether the state commitment matches between them and Ethereum.
Right, right. I think I got it, and I might reach out to you, Rahul, offline to get some more details. That I don't want to interrupt the
Yeah,
flow
of
right now.
course.
Thanks for that. Cheers.
Yeah, so as guys can see, like we have currently voted, and now we're just waiting for the proposal to end. Once the proposal ends, so what will happen is like the private key, which was encrypted at the start of election, like 5 minutes ago, will be decrypted, and the current vote tally, which is like 1-0, whatever it is, will be like shown to us. Oops. I think there's some error which I need to check. But yeah, this like ideally shows like what the error was, what the vote was, and this is a demo. As I said, like future plans are to include like storage proof, so anyone can like come up. Like there is no need to store a membership like proof. Those circuits are in progress and will be out like quite soon. Any questions?
Yeah, any questions from the crowd?
Just sorry that I repeat the question. So if I had a fork of the Ethereum blockchain, which does not have the majority stake, but which I modified to make it look like I have a lot of USDC, how would this be how could one be sure that it's not this fork which is used to prove the ownership of the tokens?
Right, Trace, I'll take this one as well. So basically, it always falls back to social consensus if a particular vote is invalid at Genesis. So suppose you're using a fork of Ethereum, and the Genesis, when it was created at block number 10,000, say, which is our threshold, at block 10,000, the state commitment of your fork is going to be different from the state commitment of mainnet Ethereum, right? So if the Genesis block of if the Genesis proof of the voting is created with the false or the malicious state commitment, any user can simply because any user can check. In fact, like the backend actually checks and raises can raise a concern that like this does not match with like the mainnet Ethereum blockchain by just doing an RPC call. It a user is like sorry the front end like the user the user can get to know that like like this is an invalid vote, and they can it falls back to social consensus, so they can talk between like people can go to Twitter or call them out, and in which case like the vote's like invalid, it is not enforced. Does that make sense?
Yeah, to me, not really, but that might be because I don't understand. Like, it could be because of me, but thank you very much for explaining again.
I can try again just like quickly. So if the state commitment is invalid, it doesn't match the same state commitment that I get from Ethereum mainnet. It falls back to social consensus that this vote is invalid. So even if the vote goes through for a certain proposal, this vote is invalid and cannot be enforced just because the state commitment was invalidated. So like social consensus comes into play here.
So if I'm an attacker who really wants to vote on something, what would be my probability of overriding the social consensus?
You're basically saying that you can override, in this case, the Ethereum,
vote.
Like the entire Ethereum community, or in this case, like Mina community or the Mina Foundation, which is improbable, or like you can override all the community members of a certain protocol, which is if that is the case, we've already lost.
Yeah. Okay. Yeah. Thanks a lot.
I saw Ivan's hand raised, but
Yeah, I'm sorry. Another
Ranuk?
time.
Yeah, so I want to add that like Ethereum will have like the single shot finality thing soon. So then you know which block is accepted by all the validators.
Yes, that is a base assumption that any block that you're putting in as threshold should at least have been finalized by the beacon chain.
All right. So if there aren't any questions more,
I think Mate had his hand up.
I think he left, but Mate? Yeah. I think he left, but he asked when protokit, so maybe we asked the like similar question. So like, what was your approach by choosing the infrastructure that you built zk Snap on, like L1 or protokit or Zeko? So what were the like facts that you considered, or like what's your plans for the future to make it scalable?
Yep. So initially, because we had already started work on zkSnap even before we knew about protokit, like we were kind of rust into a specific direction just because of initial design choices, which is why the current aggregator backend is a custom written one. However, we already have a protokit integration in the works, and V2 on top of Mina is going to have both storage proofs potentially if we can get the performance down to a T, and because we've already talked to people at Owen Labs regarding lookup tables that will make both RLP encoding and well, we specifically need decoding, so RLP decoding and other operations while traversing the Merkle-Patricia trie efficient, and we also need like an efficient version of Ketchak using custom lookup tables, custom gates. So both of those are the work. So V2 is going to have a protokit-based aggregator backend plus storage proofs as well.
One more follow-up question, as this product really excites me. Like in lieu of timeline or strategical thinking, do you have any like go-to-market strategy or business model, or did you already talk to like some DAOs or potential customers?
Yes, so we have a couple of potential customers that we have a couple of DAOs that we have talked to who want us to integrate with them. So this is like JavaSwap on Stocknet. We talked with them So they have a permissionless works model. So like they create their product using their community members, and like basically every community member that contributes to them owns a certain part of the protocol. So Jedi Swap is wants to use us for their monthly voting for their internal DAO. We're also in talks with a couple other smaller DAOs for the same. And fingers crossed, we're trying to convince Will to use us for navigators.
All right. Yeah. Good luck. It's not easy to convince you.
Yes, I'm
I'm just
aware.
kidding. Yeah. Okay. So yeah, like really well done, Rahul and Shreyas. So it's also I really appreciate the demos, videos, and the activity that you showed to the community in general in Discord and Twitter. So huge shout out to you guys. And um, the next one is Saumai. Are you there?
Sorry. Yes, I'm here. Am I audible?
Yes, yes, we hear you.
Okay, okay. So should I start the presentation?
Yes, go for it.
Okay. I'll share my screen now. Just a quick check. Can you all see my screen?
Um, I think it's loading, and yes, we see it.
Okay, awesome, awesome. So yeah, this is the final demo of Mina Ecosystem 101. The aim was to create content that can help get developers on board with Mina ecosystem within a week, and the idea was to do it by creating a video tutorial series for Mina, which would explain concepts around zk app development and how Mina works, and what are zero knowledge proofs, etc., etc. And this series would be available to anybody on YouTube. The full proposal link is there just for reference. So updates on what has been done during the course of this project. I created a video series. It's live on YouTube. I have shared the link here. Um,
Can
you
you
can
also like share the link in chat or like send us the link?
Sure, sure. Should I send the link of the entire slide, or just the
Uh,
series?
However you want. Yeah, it's up to you.
Okay. Well, anyone with the link, anyone with the link can view. Cool. So yeah, chat. Yeah. So I've shared the link to the slides in the chat. I think you'll be able to
Yes.
access it from there.
Thank you. Thank you so much.
Yeah. Uh, Okay. So yeah, the series, all of the videos are ready. The series is live on YouTube. There's just one small caveat that I didn't anticipate. So we have 47 videos in total, and YouTube has some sort of daily upload limits. So I've been uploading like 5 6 videos per day like that. We have half of the series online, so you guys can still give it a go, because a lot of the core thing is already covered there, like introduction to zero knowledge proofs, introduction to Mina protocol, overview of zero knowledge apps. These sections are there, along with one example of how to go around building your zk app. So I think most of the primary content is there. Following the fourth part, we have 5 more examples. So that would be live soon as well, within a few days. And I've also shared a link to the Google Drive where I have uploaded all of the 47 videos. So you can access the other videos from here until they are uploaded on YouTube. So that's there. And I have added a link to the GitHub repo as well. The GitHub repo. The GitHub repo contains all of the example code. These are updated as per the latest versions of O1JS. So everything is latest. I just tried them over this weekend, and everything is working fine. Nothing is breaking there. And I have I had also added the PDF. Uh, so I had added the PDF version of the slides. I think it's not showing up here. I'll add it. I'll add the PDF version of the slides as well. So yeah, it's a 10-part series. The first three parts are about giving an introduction to zero knowledge proofs, uh, giving an introduction to Mina protocol, and how ZK app work and how are they different from general dApps. The next five parts are about building ZK apps and learning O1JS simultaneously. So I introduce a few concepts with one example, then we build on it one ZK app. Then I introduce some few more concepts in the next example, and it goes on till the next five parts. And the last part is about how the viewer can, start building in the ecosystem. So since I have the slides here, I'll show the slides. Yasin, one thing I wanted to ask, since it's a video series, how do I go about giving a demo of it? Like, can I just
Mhm.
show the slides and link is there? People, the electors can
Yeah, I
watch it.
think yeah, I think you can like show the slides and like explain the topics that you covered, and
Okay.
electors will be have a look at afterwards in the videos.
Awesome, awesome. So before showing the slides, I'll just highlight the approach behind, creating this entire series. So the focus was that ZK apps and zero knowledge protocols are somewhat complex than general Web3 stuff. So the idea was, and the core focus was on reducing the friction in understanding. So the viewer should be able to understand. Um, and for that, the primary approach was to create short videos, take it one concept at a time so that the viewer doesn't have any kind of information overload. The second aspect was to use a simplified language, like reducing jargon as much as possible, again to decrease the information overload on the viewer. The third aspect was incremental learning. So it's about building on top of the concepts covered in the previous videos. So we start by giving an introduction to zero knowledge proofs and making the viewer familiar around them. Then we use that to explain how Mina protocol is designed and architectured. And then we use both of them to explain how ZK apps work on Mina. And it goes on and on. Like we take a few concepts of O1JS, build a ZK app around it, then we take another few concepts. So we keep on adding things. So the user also has some kind of recall value of whatever has been covered before, resulting in an overall better understanding of things. Then hands-on learning, as I've already mentioned, like understand O1JS by building 6 example ZK apps. There's nothing better than doing practical and understanding stuff. So yeah, so these are the slides. Like the first section is what are zero knowledge proofs, and in this is the first part. This also has its own subsections, like what are zero knowledge proofs, why are they important, what problems do they solve, how do they work, snarks and starks, zkvms and zkvms. So again, the idea behind selecting and organizing content was to cater to the fundamental questions that anybody has when they hear about these things. Like if you hear about Mina protocol and then you read that it's a zero knowledge proofs based protocol, layer one blockchain. So first question you have is like, what are zero knowledge proofs exactly? And why are they important, what kind of problems do they solve, how do they work? And there are some surrounding terms around them like snarks, starks, zkvms, zkevms. So I have tried to structure it in such a way like uh, it it answers the questions arising in the viewer's mind in a certain sequence. So it kind of follows the natural instinct of the viewer. So let me give you an example of this part. We cover what are zero knowledge proofs, why are they important, what problems do they solve, how do they work, snarks and starks, zkvms and zkvms. So we start by simple line of explainer that They let you prove that you have certain information or knowledge without actually revealing what that information is. We explain that liner in one video, and then we take an example to drive that down further with a finding Waldo example. I think we all of us have already seen this somewhere or the other. So we use this explanation to explain this one line. And I have chosen not to go very mathematical around, how zero knowledge proofs work under the hood, what zero knowledge circuits are, etc., etc., because it would again increase the information overload on the viewer, and they kind of get lost. Like the content increases and increases because of that. So we start with what are zero knowledge proofs, like why are they important? So keeping it at the bare minimum, like think of them like a certificate that can prove the authenticity of something like computation or some data. Then we elaborate on this, like if they can verify the authenticity of something like computation on data, then what does that mean? So that means verifiable compute, that you can be sure that some kind of computation has been performed without actually performing it. Then we explain, like, why is that useful? Because it can take a lot of load from the chain, making them more usable. Similar with data, like you can take a lot of data off chain and just submit a proof to represent that. Filecoin uses this extensively. So yeah, this is structured in a similar way. Now, since we have explained like why are ZKP is important from the POV of thinking them like a certificate, we utilize this mental model. Uh, these are all the explanations, again kept to bare minimum and extremely focused and concise. Uh, so take that example of thinking of zero knowledge proofs like a certificate to prove an authenticity of something. Now we use that mental model to explain the entire protocol architecture of Mina. Like, why is Mina? We give a brief overview that it's a layer one blockchain based on zero knowledge proofs, which is a succinct blockchain, only 22 kilobytes in size. Now we explain how Mina is designed, what are the problems that is it tries to solve from its architecture, and the ideas behind doing all of that. So we explain, like, the entire Mina blockchain is represented by a single snark. We start with a TLDR of the entire protocol architecture, that it's a single snark. Blockchain size is constant at 22 kilobytes, and all of this is achieved by recursive composition of snarks. Then we unpacked it bit by bit, like what is the problem. So running a full node is extensive in other blockchains, and it also increases exponentially with time. Now, why is that problematic? Because it limits scalability, decentralization, and also security. So we have identified the problem here. Now, again, we elaborate more on it. Why is it resource extensive? Because trust, entire chain history is required to verify the current consensus state of chains. And that's how we establish trust on a decentralized network of anonymous node operators. Now we take this idea that trust is needed, and we connect it with the idea of zero knowledge proofs being a certificate to prove the authenticity of something. So the verification mechanism becomes the problem. And how do we solve this problem? If we only had some way to certify that someone had already checked the history for us, like a certificate. We take it back to the way we explained zkps before, and then each blockchain update essentially becomes a snark. Now, whenever a blockchain is being verified and previous state is being checked, it the process goes entire way back. Like all of the blockchain updates are linked together in the form of chain, and that is also a form of computation, and snarks can certify any computation. So that also becomes a snark, and that's how we have a single snark representing the entire blockchain. So this is just a high level overview of how this entire content was thought about, created, structured. etc. It goes on and on. Um, Examples are also there. I'll cover some examples. Like the first example is creating a square. So, for examples, I have taken some of the examples that have been covered in the tutorials, documentation, and some of the examples are new. So this is a simple example that has been covered in the documentation. It introduces to the basics of smart contract, like field smart contract, creating functions, using state. So this touches on that, and we create a smart contract using this. We also create a script to interact with it. We deploy it on our ZK, we deploy it on the Berkeley testnet, and then we do a simple comparison with an Ethereum dApp, like how the execution happens off chain in ZK app and the execution happens on chain on Ethereum. And the transactions are stored on chain on Ethereum, but the transactions aren't really stored on chain on a ZK app. The code resides on Ethereum, but in a ZK app that doesn't happen. So these kind of things, like we go back to the core things again and again to drive the point home. Second example, like private input. Here we discuss what private inputs are: Poseidon hash function, which is extensively used in creating hashes in Mina, salt argument. Then the next example is crowdfund. Here we discuss more on account updates and transactions. So this example is designed in a way to cover these. Then we have the lottery example. Here we cover on-chain values and events. So by doing this, we cover most of the basic things bit by bit, example by example, so that the viewer is also engaged. Any developer who is viewing this, he can just go through the videos of this part in like 15 to 20 minutes, and then take the next 40 minutes to actually try it hands on. So covering the entire video series would take about I think somewhere between 6 to 8 hours in one sitting. So they can do in parts over a period of week, or they can just do it on a weekend. So these are there. And this section is the UI section where we set up wallet. We explain how a UI is integrated with the smart contracts. And the last section is what next. Like once a developer is through this journey of learning the basics of ZK app, how what more they can do now with this knowledge. So they can check out docs for more details, like getting to know the protocol in more detail and getting to understand more technicalities about it. They can join the community like X, Discord, etc., etc. So all of the links I have provided here. They can discover other projects in the ecosystem, like just have a look what other people are building, and then you can join in a program to build more stuff in Mina ecosystem. So it has been thought and created accordingly. Last section is about, if someone wants to understand ZKPs in much more detail, like mathematical technicalities, etc., etc., and other stuff around it. Like there are many other projects like Circom, Cairo, etc. So the links have been given for that. So yeah, that's Mina ecosystem 101 in a nutshell. For for the sorry, for the electors who would be viewing this, I'd highly recommend to view the first three parts, which covers ZKPs, Mina, and ZK apps. It won't take more than 20 to 30 minutes of your time, um, but I think you will get the gist of how this content was created and the thought process behind it. Um, yeah, so that's Mina ecosystem 101 in a nutshell. The proposal scope I'll just highlight, since there was a pivot in between. The standard scope was finalize the content outline via community feedback and create media content. So this was done completely. In advanced scope, I had earlier proposed that I'd be creating video animations and some good UI for a sample ZK application. But I realized that there's a lot to cover in terms of technical concepts, and I think I thought it would be more beneficial to cover more ZK apps, more examples than adding animations and videos. And about the UI, so zero knowledge proofs, like creating a zero knowledge proof application, there are a um, lot of time breaks, I can say, while using the application between various stages. So like if I load up a front end application, the ZK app compiles, then a transaction takes place. It takes its own time to uh, get verified on the block. So I decided to tone down the UI a bit as well. So the initial proposed advanced scope was to add video animations in tutorial series and deploy a sample ZK app with a good UI. The pivot was around reducing design elements and focus more on covering more concepts about O1JS. So finally, what I have delivered is that two additional ZK app examples I have covered. One is the crowdfund and one is the lottery. So we cover more O1JS concepts. And I have deployed a Square example with bare bones UI. So yeah, that's Mina ecosystem in a nutshell. Happy to take any questions or anything.
Yeah, thanks, Samar. That seems like lots of content. I see a hand of Ivan. Right?
Yeah, just a small question. In the beginning of your presentation, you mentioned like 40 plus videos, if I'm not mistaken, right?
Yes, yes. It's 47
Yeah.
in total.
Yeah. And, so how much videos do you have actually by now?
uh, on YouTube. So I have shared the link to the presentation, since I am limited by a daily upload
Yeah,
limit
yeah,
kind
yeah,
of
yeah,
thing.
yeah. I heard. I
Yeah,
heard.
yeah.
I
Yeah.
mean, how much is in the queue?
I think on YouTube, let me just check. On YouTube, we have
I
somewhere
mean, not
around.
only on YouTube. I mean, ready videos.
Yeah, ready. All of the videos are ready. I'm just
Ah,
limited by the daily upload limit. So if you want to access all of the videos, the drive link is also there. All of the
okay.
videos are there, like all 10 parts. On YouTube, we have reached till fifth part. I'm constantly uploading it as I can, but all of the parts are ready and uploaded there on the drive. Link is there
Hmm.
in the presentation. On YouTube, I think half of it is there, somewhere around 28-30 videos out of 47 videos.
Okay, great. And
Yeah.
the another question was like in the presentation, like obviously we cannot sort of watch all the videos right now and see
Yes.
what's in there. So
Yes.
what so in the presentation you mentioned like the topics for first one to three videos was this, and the topics for fourth to ninth video was this, and the topic for 10th video was this, but
Yes.
like you have 11 plus videos, so what are the topics for other ones?
Okay, okay. So, yeah. So I understand the confusion there. So there are 47 videos. The content is structured into 10 different parts, and each part can have its own section. My screen is visible, right? I'll show you. So there are 10 parts, but each part has its own section. So, like the first part is what are zero knowledge proofs. Now this has its own one, two, three, four, five. This has its own six sections where
Okay,
we,
got it.
yeah,
Got it. Thank you.
yeah. Happy to take any other questions. Thanks, Will. Thanks.
I think that was
Uh,
great. Yeah, I think we should probably keep it moving just because we have some other projects to get through. But really looking forward. I just shared this with the Mina Foundation team as well, and
yes.
a marketing team to get some more eyes on this as we go. But this is very extensive and like Mario said, much needed. So thank you for your help.
Yes. Thank you, Will. I just had one question, like about the future scope. I was thinking around building some kind of online ID that can help the developers, get onboarded quickly. They can fire up that ID, just like Ethereum has remix sort of thing, something on that lines. Would that be a good idea?
Yeah.
I
Uh,
think
uh,
I think we need to discuss this out of the scope of this demo
Present.
sessions.
Oh, sure, sure, sure.
Yeah, I was just gonna say I think for the future, maybe the best question would be like researching what's already out there. And I think Elton has mentioned that Mina Playground is there, and we also have
Okay.
Easy Mina and a few others. And so from my
Mhm.
perspective, I would like to see the community working together and figuring out how to plug gaps rather than starting from scratch. Um, so yeah, I think it depends.
Awesome, awesome. I'll look into it and see what I can do.
Okay, great.
Yeah,
All right, thank you
thank you.
very much, Yasin.
all right. So next one is Anush. Anush, are you there? I think you're there. Tanush.
Hey guys,
Hello.
Hello.
yeah, I am here just to watch actually.
Oh, okay. Then
Yeah,
let me. So yeah, just let me check with Anush a second. Yeah, as we went faster than expected. So, but he's joining right now. Only.
Yeah, I would say, well, Yasin, your decision.
I mean, let's wait for 1 minute because he just told me he's joining. So if he's not joining in 2 minutes, we can continue with Carbonara.
Maybe I can, while we're talking about different levels of information that are helpful to people joining the ecosystem, I think we're now getting to the point where we have Lawrence, who's working on the Learn to Earn curriculum for as part of the Mina Navigators program, but where there's some very kind of like in-depth zk concepts and also related to O1JS that we're working on there. So I think that I'm thinking about as the more advanced part of the funnel. And then I'm thinking about videos like Samai. Is it Sammy or Same? Samai. Sorry, I don't know what the right way to pronounce it is.
Yeah, it's Some.
Same.
Yeah,
Okay,
yeah.
thank you. So I think Same's videos are great for this, like as Mario said, kind of someone comes in for the first time and doesn't know where to dig their teeth in. And maybe there's an opportunity for some kind of like environments related to that. But what is becoming clear to me, and I think it's been something that people have been calling for a long time, is we still need to do from Mina Foundation perspective, like how do we organize this information in a way that's useful to the community. So part of it is we've just been doing a lot of things at once, and I think another question is like how do we keep up with the new infrastructure that's being built on top of Mina that would be integral to the development journey, such as like ProtoKit and others. So if you guys are thinking about it, we're also thinking about it, and we need to think. I hope we've already shown some improvement in terms of what was available 6 months ago compared to what was available a year ago. But just know that I think my shift is now thinking more about the organization of the content because we now have a plethora of content that's available, and I think it's really healthy to have different levels which we've seen happen organically. So,
Yes, yeah, happy to help with promoting this and spreading it out in other channels. I'll be posting the YouTube links once all the videos are uploaded. But you can let me know if there's other places I should post it.
great, thank you. All right, yes.
By the way, we can continue with Carbonara if it's okay, because Carbonara, are you there?
All right. Okay, just let me try to share the window. Okay. And let's see. All right. Okay, so yes, welcome to the presentation of the App Store. So just to give an overview of what is the App Store, the App Store is a platform where developers can submit their ZK apps and showcase them to the community. You can imagine it as a little bit like App Store for ZK apps or an NPM for ZK apps. Why we are doing this? First, to have a central point for gathering all the ZK apps, and secondly, to provide this data to third-party softwares, like, for example, wallets. We made our proposal on zkIgnite 2, Cohort 2, and our milestone essentially was to build ZK App Store, so a marketplace that has search functionalities. You can sort ZK apps by categories. You can have a private dashboard for the developers to submit the apps, and APIs and documentation. So let's the progress. We deployed ZK App Store at the domain zkapp.store. We have the docs at docs.zkappstore, and the API is available at API ZK App Store. We will go through them. So first of all, I would like to show you the platform, and just do a quick refresh for starting fresh. And this is our homepage, where we can see like the trending apps, ZK apps, categories, and the feature ZK apps. So there is one thing, as our little helper here says, this is preview version of the ZK App Store with mock data. So all the data that currently you see is not actual ZK App data, but is just mock stuff. Why? Because this kind of data is submitted by developers, and of course we just finished the development of the project, so we didn't manage to gather yet the developers on board. So the data here is a kind of AI generated data. But continuing with this, we can see like categories, and if we go in identity category, you can see like what are the main ZK apps developed here in this category. If we open, for example, this secure login gatekeeper, the developer, in this case, Small Chunks developer, submitted this ZK app with the description of the app. Of course, this is mock data, and you can use the ZK app by going to the ZK app domain. So reviews, stats, audits are not part of this cohort. These are functionalities that will come in the future, but currently there are no reviews possible to be made on the platform. We can go together at the Small Chunks developer profile, where we can see what ZK apps this developer developed. And let's say that we really like this app, ZK app, we can just have it in our favorites. which then we will have it in our favorites. As I was telling you before, there are categories which we can explore. And also, of course, as I am like a developer here, we can log in our private dashboard. And here I can manage all the apps that I developed, and can just go in our Markdown editor and just say hello, and this will be saved in our zk app presentation. I can, of course, publish a new zk app with my the information of the zk app, the description, the GitHub URL, Discord, upload pictures about the zk app, and yes, essentially for now that's it. I mean, of course, I the developer can also improve the profile by having a bio, social links, and so on. Social features like follow currently is not developed, but of course that's another feature that will come soon. So essentially this is the application, of course, is open source on GitHub. And for now I would like to move to the next chapter, which is the API. So at docs.zkappstore we can find like the API with so the API is GraphQL, as mentioned in our proposal. GraphQL is a little bit native at Mina, so yeah, we stick with that. Well, we have all our queries, for example, where we can search the zk app by name. We can get zk apps by categories, by user, and so on. Of course, this is something that is going to grow by the time with the new features coming in. And these APIs can be used here at zk App Store. And as an example, I prepared a little example here where we can search an app by name. In this case, we search by NFT, and we have NFT Guardian, which has the URL, the developer, the category, and all that stuff, like social, images, logos, and so on. Of course, there is all the other. There is also mini documentation here, which is part of GraphQL. To give another example, if we type secure, we should find all the data which are named secure, which is a lot in this case. But yeah, so that's it essentially. And just to close, I would like to say that if you're a zk app developer, would really love if you could visit us at join.zkapp.store, and there we can there is a small kind of wait list, or it's just a Google form where you can express your interest in submitting your zk apps on zk App Store. And that's it. And if you have any question, I would like to answer them.
Yeah, first of all, well done, Carbonara. I think the UI is really sick. I really like the design, plus the penguin list. Ivan, yeah, Ivan.
Yeah, I just wanted to ask a small question about from what I've seen from the demo, I see this is a sort of zk app list, but you call it marketplace, which implies some monetization or something. Can you elaborate more on how developers can earn here, if there are some ideas on that?
Yes. So that's a really good question because I'm also not 100% happy about the term marketplace. We started with it. We just stick with it for now. But we think that this platform, it's a base for more things to grow on top. So actually, um, our plan is not only to have this platform like this, but also to develop into analytics branch. So it's like, let's say this is like a starting ground for us to see where we can lead, but we believe that such platform can help to bring new revenue streams for developers. So in, of course, marketplace like sounds like you are about to sell zk app, but for now it's not like that. But we don't really know if maybe one day we can perhaps go into a branch of, in a similar branch of an app store or something like that. So yes, I agree with you that probably at the current stage, marketplace is not the most correct term that we can use, but we see that there is some potential of revenue streams for developers. I don't know if this can uh, helps as an answer or makes more confusion.
Okay, all right, thanks. Thanks, Carbonara. I'm just talking to um, Kaushik because he's co-founded an appointment. Just a second, please.
You're welcome.
Really sorry. I'm just waiting an answer from Kaushik. All right, let's continue with Anuj. Are you there?
Yes, hi.
Okay.
Can you hear me?
Hello. Yes, we can hear you. Yes.
One second. So do I start sharing my screen or?
Yeah, please go. Anuj, we can see your screen right now.
Is it visible now?
I think yes, it is visible right now.
Yes, hi. So good evening, everyone. So first of all, I would like to apologize that I've had cold this week, so my voice is really terrible. So let's get started. So Doot is an enhanced oracle for the Mina protocol. This is the first glance of the protocol. So we have these multiple pages. We have asset prices. The prices that are fetched are aggregated and filtered, and you can also verify the results using the user interface. And we have much more to come in the future. So this is like just a testing ground for this. So we are currently tracking 5 asset prices. So as you can see, like this is for Mina, and the current price is about $1.26. This is the last timestamp of the fixed prices. This is the photo. So first, I'd like to take you guys to the dashboard. So I've already registered with this one. So what it does is when you go to the dashboard, it asks for your signature since it requires that the person who's logging is the actual owner of the address. So after you have signed it, you can get your API keys from here. So the current model of Doot is like you produce your API key using the user interface, and we have an npm package that can be used directly in the interacting scripts, and you'll have to put the API key there, and you can fetch the prices directly in your interacting scripts. So let's assume like I can join from a different account. So I'll just create one now. I'll switch over to this one. When I reload the page, yeah, you can see like it's asking for a request. Go over it. Yeah, it sees like this is the first time you're logging in. It asks for onboarding. So what this is doing it at the back end, creating the user profile for the user. It takes a couple of seconds. And it should be done by now, I think. Yeah, so it asks for a signature now. And as soon as you sign it, you get your API keys. So this is how the user onboards to Doot. After that, we have feeds, like this is just for the user interface. These are the current prices that are being tracked. So let's go over to Mina. So we are currently using these 11 data providers to fetch the prices. So as you can see, like this is the number of providers that were used for this specific price was 5 out of 11. So all of the providers that were actually considered 5 out of 11. And this was the final signature for this price, the data, and the Oracle public key. We can also see like we have historical information that is up to the final, up to the past 2 hours. So I had to redeploy everything just to get things like from a clean slate. So this was the main page. So we can also go to verify. So this allows the user to verify the signatures that are produced. So I would like to show you guys one more. Like if you go over and go to the feeds, like if you see, we have one aggregated signature, an aggregated price, and aggregated timestamp. So let's say for serial number one, we had all of these data providers coming in. These were the signatures and their respective prices that were fixed and the timestamps. So the aggregated price is the after doing the outlier and the aggregated mechanism, you get this final price. So if you go over to, if you copy this, this is the price, and this was the aggregated signature. If you see, like you can see that the signature was indeed generated by the Oracle keys. So let's say if I do something else, like I add some impurities. So you can see like the person can verify that the signature did not originate from the Oracle keys. And we also have an individual request verification. So if we go over to say coin market cap, we take the signature. This is for Ethereum coin market cap. We select so the URL is produced on its own. We get the timestamp. And finally the price. And these are the decimal places. So every price that you see here is multiplied by the power of 10 to create a string like this, since we cannot handle floating point numbers directly on Mina. So if I submit it here, it takes a couple of seconds, I believe. I think I've missed somewhere. I'll get back to this later. So this was the verification page. So Now I'd like to show you the actual backbones of the whole protocol. So this is the main interface. So what happens is like we have multiple cron jobs running on the protocol. If you go over to, where is it? Yeah. So we have these multiple cron jobs running. So like we had 5 separate uh, assets that we are tracking. So every time these specific endpoints are called at the interval of 10 minutes for now, just for the sake of keeping things in a more consistent way. We also have two other part of things. One of them is update historical. The update historical, this part of things, like this is managed by the update historical. And we also have update Mina. So the update Mina thing is we had a fallback layer on Mina protocol too. So what it does is, I'll show you. So we fetch the recent prices for that specific interval. And what we do is we create a Merkle tree and their respective key value pairs. We update the commitment, and finally we pin this object to IPFS. So this or the IPFS holds the witnesses, the key, the values, the commitments of the final thing, and all of the asset information that we have. So maybe if we go over here, I've already ran this once. So this specific thing is available on the Mina protocol. Uh, this was the IPFS hash that was pinned over there, and the commitment. This IPFS thing is actually coming from the interface and not from the, what do you say, from the Mina contract itself. So these things are available on the Mina contract. Now I'll take you to the Mina contract. So this is what it looks like. Since we have a storage limitation as of now on smart contracts, we plan we are currently taking in the Merkle root values just to create a stamp on the Mina protocol. So we have the secret token, the IPFS CID, and the commitment. So every time a person updates something, the commitment and the IPFS CID is updated accordingly. And this is to initiate everything, and the person can also verify. This specific part is for the aggregated price and the aggregated signature. uh, I'll take so like as you can see, like this is the current Mina protocol contract that we have. This was the deploying transaction. This one was to initializing the base values for the IPFS CID and the commitment. And after these three are to update those values. So initially, like we have this init base function. This can only be called once, since initially the secret token is set to 0. But after a certain while, like the person updates the secret and the secret token is updated, and finally you can update the base. So this limits the person usage to the Oracle only, since right now anyone can use the Oracle public keys to send the transaction. So we thought about this, and we finally agreed upon to use the secret token instead. So this is how it looks. So sorry, I should have started from here. So this is the presentation. So initially, how things were done, you were meant to create your own API endpoints. It was really hard to include multiple data points, and after that, you were also supposed to make them OpenJS compatible, and finally fetch your data in your interaction scripts. So what are the drawbacks? It takes a lot of time to set things up. Having multiple data providers increases the complexity. Also, if you're using single data providers, they are more prone to failures. And also, like if the zk app developer is working against the users, they can always change the data providers and present the users with untrue values. So we wanted to be a seal of trust for that. Our approach is simple as that. You use the user interface to get the key and use the key to fetch the prices. So I'll show you the, what do you say, the npm package now. The npm package is pretty straightforward. As you can see, like, these are the valid assets that we're tracking right now. You have the client class. It checks if the key is valid. So we have these get key status API endpoints available on the protocol itself. So it sends what do you say, an Axios request to it, and it sees like if the status is valid, so the key is valid. Now the main package, the part of the main function that is used by the package is the price. So you're supposed to just send the asset, and it returns a client result. The client result is supposed to be the asset, the price in with the type of field, decimal in the type of field, the signature, that's the type of signature, and the timestamp. So what it does is it calls the get price API endpoint at the protocol. So after fetching the information, you everything is translated to, what do you say, OpenJS compatible data feeds, and the client result is pushed back to the user. So this way they can interact with, they can be sure of getting the most uh, diverse and the accurate information as possible. So I've already done the UI walkthrough. We just had the package walkthrough, the backend fetching walkthrough. Yeah. So I'll give you a small peek into how the, what do you say, the prices are fetched. Hmm. Get price, update price. So we have these different symbols for each data provider. So this is essentially the heart of the protocol. I'll get to it. So this is like create array asset info array. So what it does, it calls each function. So I'll just give you an example. So let's skip over to this. So what it does is we have the API endpoints for each data provider. We have a result path of the final, like where the price is supposed to be. Like usually when you call an API endpoint, you get multiple results in the JSON object. So this is to get to the point where we get the price. So after this, the call sign API call. This is where the magic happens. You get the price. This is converted. All of this is converted so that we can sign over it. The client signs the fields, the URL, which is what do you say, derived from the circuit string. We have the price that is fetched by the data provider. The multiplication factor is set to 10, like I've mentioned before. This is because Mina doesn't support floating points, and this is the timestamp when the information was this, when the URL was called. So it's coming from the response headers. So you sign over it using the Oracle keys, and you finally return the compatible data. So I'll show you like how it looks like. So if you say I'm getting the price of Mina token, so we have, this is the aggregated price, these are the decimals, and this is the signature over the aggregated price. These are all the URLs that were called. These were all the prices that were returned, and these are the timestamps of the headers. And for each for the set of these three things, the prices returned, the URL, and the timestamps, you get individual signatures over them. So these are all for individual data providers. So the first one is for, let's say, my bad. Mm, yes, sorry. So for this URL, this price, and this timestamp, this was the signature generated. So I think this is most of it. and the Mina data walkthrough. And this was the same thing that we had here. So this returns the IPFS hash of. So these three IPFS hash, Oracle address, and the commitment is available on Mina L1. Rest of the things are all handled by the protocol, and every what do you say, the prices are cached using Redis, and during for different intervals, the prices are updated every 10 minutes. Every 2 hours, the information that is currently running on is updated, and the historical prices are updated every 30 minutes. So this is the essence of the protocol. Thank you.
Thanks, Anush. Are there any questions? Yes, Ivan, please.
Yeah. Yeah, my question would be maybe a little bit strange, but anyways, do you recall what we have on the Mina documentation website in the Oracle tutorial section? Like we have an example of experimental of chain storage. Have you seen that?
Example of what?
Of experimental off-chain storage.
You mean zkfs.io, I think.
I mean, like on the official Mina documentation, like the
Experiment of storage. Yeah, I read about it, but I don't exactly remember it. Yeah.
yeah, no,
What's
no
it?
worries, no worries. What I mean is that, like, do I understand well that the architecture, like basically the architecture here is sort of the same, so that you have this backend which, like, sorry, I didn't follow all of the points you described. So but just to double check, double confirm, do I
Yeah,
understand
sure.
well that there is like a backend service which updates like the price feeds, whatever, or some other information requested by the client, and continuously updates the smart contract with new data?
Yeah. So the thing is, for the npm package, the information that you get is based on the what do you say, the minimum time span of 10 minutes. And on Mina, you have uh, the latest price that you get is like 2 hours. What do you say, in the past? So essentially, like, you can fetch the data from the what do you say, the Mina L1 if you want to, or you can directly use the npm package that you get your API keys and you call directly in your interacting scripts. So instead of doing everything on your own, like this makes the process autonomous, and all you need to do is just call the API, get your price, and you can just verify it directly on what do you say, on your smart contract, like this price was originated by a specific public key.
Okay, got it.
Yeah, sure. One
Yeah,
second.
there is a question in the chat. I believe you can send a link to chat so that people can review the contract async.
It's everything is available on the GitHub. I can just share you the link for that if you want to. One
Yeah,
second.
great.
Ronuk, do you have a specific point around your question, or yeah?
So under this GitHub repository, you'll find the multiple subparts of this thing. So the L1 contracts is where the fallback layer for Mina L1. The web application is the heart of the protocol. You have the package. So earlier we wanted to go for this project using zk chain, but it turns out it doesn't have what do you say, a hosted service as of now. So I had to fall back on your native web2 approaches for that. What I had in mind earlier was to like keep everything on what do you say, protokit L2 and push just the final results on L1, but it isn't feasible at this point.
All right. Any more questions?
Like I just want to say, like, I understand like 30 minutes is too less to like exactly explain the whole protocol.
Mhm.
So if anyone would like to like get into details of it, you can contact me. I have no problem with that.
Thanks, Anush, for welcoming more questions and opening more discussion. So appreciate the work. So
Thank you.
I talked to our last presenter, Kaushik. Normally, like their presentation was scheduled in 20 minutes, so they planned it accordingly. That's why like we will give it 20 minutes of break. So guys, feel free to like leave or stay. I'll stay here like for 20 minutes to wait for them to present. So I'll be back in 20 minutes. Yeah, thanks again for everyone joining here, commenting, asking questions, and of course the stars of the day who are the builders. Yeah, Anush, please. I saw your hand.
Yeah, yes. So Ivan, if you want to talk about the L1 thing that I mentioned, like we have some time. So,
Yes, we have some time if you wanna show it and like talk more. Run it.
Yeah. Yeah, so we have time. So what I wanted to know was like what's the use of this state-based update and all like the functions that are present in the L1 contract and who will be calling those and can you describe it
so
a bit more?
yeah, sure. So the everything, so user will only be exposed to the variables that we have in the contract itself. If you go over to the repository, just give me a sec. Open it. So we can see like we have, what do you say, four, three essential state variables: the commitment, the IPFS CID. Oh, wait. I understand what you mean. Never mind. So I actually forgot to push the test branch back into the main branch. So if you could go over to the test branch for the L1 contracts.
Sorry, Anush. Did you?
Yeah, I was saying like, who was it? One second.
Yeah.
Hello.
Back. Hope you're doing well. Hope you're feeling well.
If you go over to the
Yeah, I think it will be better if you can
we
share
have
your screen.
variables, the
You can
commitment.
share your screen.
As per the, am I audible?
Yeah, we couldn't hear you, but right now, can you try again? Speak.
Yeah, am I audible now?
Yeah,
Yeah. So I was saying like if you go over to the test branch and open up the contracts, you'll find
yeah, it's here.
you'll find four state variables. So the commitment, the IPFS CID, and the latest change start. So the plan was to like create a fallback layer if the npm package fails to fetch the data from the user interface itself, and fall back to these values. So this will make sure that the person is getting at least 2 hours previous data and not really outdated one. So this was essentially why the main purpose for the Mina L1, since mining every block sometimes take up to 10 minutes, I believe.
Oh, okay. Yeah, got it. So the Oracle is supposed to call this uh, update individual every
Yeah, yeah,
10
yeah.
seconds.
So all of the update features are done by the cron jobs. Like the user have no relation with that. The only thing user is concerned with as of now is the npm package. So the npm package essentially just calls the, what do you say, get price API endpoint based on the token that you are trying to track.
Oh, yeah, got it, got it.
Like most of the protocol is autonomous, like the person doesn't need to do anything, and that's what we were aiming for, to streamline the process and make Oracle integrations much faster and much easier for the users.
Yeah, got
So
it.
we have tried to take care of everything. Thank you.
Yeah, yeah. And so another question I had was like, do you have plans to like decentralize the Oracle network like in
Yeah.
Chainlink?
So what I was thinking about the project is right now it's really centralized. What I want to do for the next iteration of Booth is to, instead of create like having this autonomous function, the users would be able to enter their data providers and the specific JSON key that they want to fetch from it. And this will create, what do you say, zkVM for them. And essentially the computation, we will also have a proof of computation for the whole like endpoints that the user wants to call, and it will exist on the user's end only and not as a centralized entity. So we are looking at risk zero for that as of now.
Yeah, yeah, that makes sense. But like uh in Mina with zero knowledge, so we can explore that you can prove the HTTP handshake like TLS notary, what TLS notary does, right?
Yeah, yeah, yeah. So we also have that project incoming this cohort, I believe. So yeah, we can definitely make use of that. So I just wanted to like get at least the first iteration of the protocol out for everyone to use. So since we at least need a single point to get started from, right?
Yeah,
Yeah, I understand like the process isn't as decentralized as the person would want, but it's a good starting point for everyone to like forget about or like making their own oracles and just
yeah. Hmm.
download a
And
package and get to it.
yeah, that makes sense. And so I you said earlier that you tried PhotoKit as well. So
Protocol, yeah.
so like what
So
was the issue like
so
what issue did you face with that?
so the thing is like for ProtoKit to work, like it exists on local machines as of now. It isn't, it doesn't act like a hosted service. So everything that I do will stay on my local machine and not be available for everyone to use. So that just
Yeah.
that loses the point of having a single point like person can call and get the data.
Yeah, yeah, that makes sense currently, but currently, like in Protocol, a bridge is not there, like from the L2 to L1 bridge.
Yeah, yeah, that too. But the main thing that made us move away from ProduktKit for now was the fact that there isn't a hosted service, which I believe
Mm,
like Mathurs is gonna launch soon, and I've already talked to him about it. But yeah,
yeah. So another thing you can focus on, like suppose like a Protokit app wants to use the Oracle inside there, they can still use that, like how they can use that.
Yeah,
So they
so
can call the API to get the signature, but uh, what you can do is like you can create some protokit runtimes which provides the public key of the Oracle. Then
yeah,
like any
yeah, yeah,
protokit runtime will also able to use your price feed.
yeah, exactly. Yeah, I mean, as soon as we have the hosted service up and running for ProtoKit, I'd be more than happy to like switch everything over to the what do you say, ProtoKit L2.
Yeah. No, I think this is fine, but I wanted to say that suppose a protokit ZK app wants to use the price feed.
Yeah.
Yeah. Like how
Oh,
will
it's
they
to make
verify
it
that?
to,
Yeah.
to make it runtime module compatible, you mean, right?
Yeah. Currently it's easy for a smart contract in Mina L1 to use the price feed, right?
Yeah,
But
yeah. It's straightforward to use it in Mina L1 interaction scripts, but it's still
hmm,
relatively harder. Like I haven't explored ProtoKit for Doot as of now. Like it didn't came across my mind since ProtoKit is also developing side by side.
yeah.
But guys, I'm really happy to see the discussions and yeah, seeing you guys. And we'll have one last presentation for this session in 8 minutes. Just for your information. Yes, Mina. Mina is the way.
Thanks, everybody. I've got to run. Just I've got another meeting, but thank you to those who presented. I'll be on the others later today. Yasin, thanks for holding it down, and I'll watch the recording of Maya. Sounds good. Okay, I'll see everybody soon. Thanks again. Onwards, upwards, all that stuff.
Yeah. See you all.
Bye.
Bye, Will.
Bye bye. Welcome, Pavel. So we'll have one last presentation for this session in 5 minutes, just for your information. Okay, hello, Kaushik, are you there?
Yeah, yeah, I'm here.
Yeah,
Am I audible?
yeah, we are ready. You can
All right.
start. Yes.
Cool, cool. I'll just present my screen.
I'll do it, Kaushik.
Okay.
Yeah, cool. Yeah, hi guys. Sorry. So thanks for waiting. We'll start. So this is kind of the status report for Maya, which is the project we were working for this cohort, and we got a lot of progress done. So yeah, uh, here's the thing. So just a quick overview about what the tool was. It's a dev tooling created to make easier things around like for developers so that they can easily get started with the boilerplate code, as well as uh, they can also check upon Mina through the CLI tool itself. So this is a kind of a cool dev tooling, because this way the coder can start easily with a new project, and as well as like get the blockchain status, right? What's the current block height? What is the balance of a particular address, and so on and so forth. Like a lot of queries you can make simply via the terminal. So the project team members and the org is currently on the GitHub. We have all our repositories which are kind of open sourced, and the ones which are good to go, all of them are open source. So yeah, um, the milestones which are reached so far, we have tons of boilerplates which are ready, and we already shipped a particular version of the CLI tool on npm. We created multiple tech stack boilerplates and also started with the Rust CLI. All of the entire architecture is kind of modular, so it can be migrated, and it can be updated quickly, so that there is no issue like a monorepo kind of thing. Here are like simple quick looks, like if none of it made enough, like these are kind of the action tools, like how the actual terminal looks like. I can present it right now as well. But here are a few screenshots which explain how it will work. You can check upon like the current circulating supply, the state hash, like which is kind of required as well for any developer in the space. You can put up public keys and just get the total balances. And depending upon the framework of your choice, it will even create a cool front end around you. So yeah, the front end boilerplates. I'll present all of this right now, like how it works actually. So let's do that. Let me just present the entire thing. So yeah, I'm presenting the entire screen, and so the tool simply asks what all you require. Now let's just query for everything, and yeah, we can fetch easily whatever we require. Currently, we are making simple calls and trying to make it as quick as possible to just like get it. It's a simple JSON point, and there are few more things like create front end, which is kind of like which has multiple boilerplates, and it will work for any tool way. It will install your node modules and it will be good to go. So whatever you name it, we have the entire components ready to go. We deployed this particular next boilerplate template as well on Vercel, which is a place where you can test it, how it looks, and yeah, a lot of simple queries as well, like how you can even check the balances and whatsoever. So yeah, a few more commands. We are working on the documentation side of it, as well as like a Rust CLI version of it, so that we saw that there are a few libraries of Mina which can actually help out. And the Rust language, the earlier CLI tool, we are calling it the V1. It was created in TypeScript, and we started with the Rust thing because it made sense to have a Rust CLI tool as well, so that we can add more features. But yeah, it's this currently which we started like just this week, and it's in our it's an additional goal which we added in our milestones to reach. So yeah, here is how it looks when you want to have an XGS 13. When you spin up that particular XGS 13 boilerplate and actually run it. So yeah, it simply connects, and yeah, we can simply have it. We are fetching the balance, we are fetching the address, and few more functionalities. We have a lot of hooks. All of them are like modular, so they are available as different hooks as well. But yeah, this way we can have different things about how easy it will be to develop projects on top of Mina. And yeah, the CLI tool helps out with that. So back to the PPT. This is These are the front end boilerplate screenshots which I just showed. Here's the current status about how it all looks. So we are done with building the MVP. We are done with React.js template, the Next.js template, and we are switching to more tech stacks so that we can cater to more audience and more, a huge developer database as well. And the next thing would be to start creating content around the tools so that it can be a starter plate for it will be an easy start point for developers to get into. So we already started it. We worked upon uh, different documentations and like handles, and also like starting to build like tech tutorials around the tool so that those can act as something as a developer content. And we would like to showcase them in upcoming Mina hackathons and the upcoming cohorts through which we can get the early access developers, and the developers can get an access to these tools so that their projects get easier to build. So yeah, that's the current roadmap as of now. We are done with building the MVP, which we started back in like late November. We added more tech stacks and worked on like hosting it and getting things done in December. And January, we are totally focused upon distribution of the tool. We already started creating the docs on Gitbook, and also working on a Substack through which we'll be publishing the tech tutorials around the tool. So yeah, this month it's all been about like making the things easier to use, having public links so that people can test it very quickly. And yeah, these are the links which are showcased as well. So that's majority of it. I guess Kaushik can help out explaining more regarding how the front end part of it works.
Yeah, thank you, Harsh. So coming to the front end part, the boiler part, we are actually looking into creating multiple hooks, which includes sign-in transactions, sending transactions. And the reason we started with Next.js is mostly because since Mina is built on top of TypeScript, and we wanted to start with something that is more familiar for students and friendly coders, right? Our main goal is to get beginner coders and provide them with these hooks um, to have it integrated easily and introduce them to blockchain as well. While the CLI also acts for non-coders, they can easily implement this. And with CLI, we are planning many more things, which is in the pipeline. We'll have updates in our Twitter as well as in our LinkedIn. I think Harsh, can you just move a couple of slides on the right? Yeah. Yeah, so here we'll be posting all the updates regarding our CLI as well as our hooks, the multiple hooks that are in the pipeline. Yeah, that is there. Apart from that, just a second.
Yeah, just a thing too I wanted to add. We already the sixth version is already published on NPM for people to use it, and it has every functionality. The documentation currently is just README. We are working upon having more better dev docs, because being developers ourselves, we understand that the better dev docs are like something which works when you copy the code and it just works, and that kind of thing. So yeah, It's already live on npm. We will soon make the Rust tool as well live, which will be another CLI tool on the Rust. It will be a Rust crate. So yeah, that way we'll make sure that both have similar functionalities. It's just that Rust has few more options to like access few more libraries, and just makes things much easier for like the user point of view. Like for the developer side of view, for us it would be a little bit tough, as like writing vanilla Rust is going through a lot of different libraries which are existing and so on and so forth. But yeah, for the users it would be much simpler, because a lot of can be done using those libraries.
Yeah, and in addition, we are also interacting with a lot of colleges, trying to introduce them to Mina through our boilerplates. So that is also that we are currently in progress with. So yeah, Harsh, just the next slide.
So yep,
Thank
that's
you.
the progress we made since like the past 2 months, and yeah, we are open for questions.
Thanks, Harsh and Kaushik. Ivan, please ask your question.
Yeah, I have a few questions. The first one is looking on the check balance and check Mina functionality. How is it different from using the Explorer to check all of these metrics?
Yeah, it's we are fetching it from different as well, but it's just that the CLI tool, we wanted to make the developer experience better, and there was already a like we wanted to have like different type of boilerplates. If you are familiar with having WAGMI, which is a dev tooling for Ethereum ecosystem. It has multiple hooks, and we kept that in mind like whilst building this tool. It has multiple hooks through which you can fetch the current blockchain data, and if the particular project requires that, you can just call that hook and you'll be able to fetch that. It's similar to having it in Explorer, but it's just that in like we wanted to have that as a functionality for developers to use it.
Okay, got it. And the second question is you have this front end boilerplate sort of and the question is how it's different from the one created by zkApp CLI.
It has more hooks. I guess Kaushik would be the better person to answer this.
Yeah, so a couple of things is that first of all, we are focusing more on the hooks part. We are not focusing more on the UI part. We are giving the freedom for all the developers to use any sort of UI a framework library, UI library that they want. Although we provide Material UI and Daisy UI with it. However, as developers, they have their own personal choices. So hooks are the major part in this. So they can just directly integrate the hook, and they can use the context provider and then implement it. So
Can
that's
can you quickly run through this example front end application?
Pardon?
Can you quickly run through the boilerplate front end application?
Sure. Harsh, can you just share the webpage?
Sure. So this thing. This is the live link. We have hosted one of the versions of the templates on Vercel as of now.
Okay, cool. And what do you mean by hooks? Like, do you mean React hooks or?
Yes, React hooks and Next.js hooks. That's correct.
So, is there anything you're kind of proud of, like in terms of these hooks? Like, I don't know which ones do you have, and which ones do seem more valuable?
So yeah, we have a couple of hooks which are balance hooks and account connection hooks. So when you connect an account, if you have to do it with Aura, if you want to connect to Aura wallet, you have to write the whole code completely. But with a hook, you just have to specify it on the starting of the page and use the context provider and put it between wherever you want it exactly. And yeah, it is just 2 lines of the code, 2 lines of code instead of having 20 lines of code with the hook, without the hook. And we have
So
yes, pardon?
it's about simplification, like of interaction with the wallet. Okay.
Not only wallet, anything wallet is just one of the examples. We do provide a hook for wallet connection, but it also includes balance. It also includes signing and sending the transaction. Suppose if you are interacting in an app and you want to say, hey, I want to transfer 10 Mina to another person, another user, you can, in order to do that, the whole complete code has to be written, which will be a lot of lines, but with the hook you can easily do it in 2 to 3 lines of code. So we're making it very friendly for developers as well as beginners with this.
Okay, great. I think this I really like the how you worked out on the front end part, and I wish it was on the zk app CLI, like integrated into zk app CLI functionality, so that like the developers who use zk app CLI can borrow from your boilerplate. That would be great.
Sure, I'll ask
like
Yashin if he can help us with
yeah,
that.
we can make a PR from that to that. So it's totally like we are open sourcers and we enjoy that. So yeah, we can make a PR on zk CLI.
Yeah, that would be great. That what I'm talking about. Thank you.
Thank you for the question.
Right. Yeah. Thanks. I think these were like great questions, Alan. And are there any questions from the crowd? Right. If not, I want to thank Kaushik and Harsh for the hard work and all of you. So this is literally the end of our first session. I think it was amazing, and I hope to see some of you in the second session. So see you guys. Bye bye.
Cool. Bye.
Thank you, everyone. Thank you.
See you.